Setup on which the students are expected to do the port timing diagram. So this is a cut section model of a two-stroke petrol engine, right? So here the entire operation is completed in one rotation of the crankshaft, and so basically for the one rotation all the operations need to be completed: suction, compression, power and exhaust. And in order to make it complete in one rotation, here some operation is happening on the top of the piston. Suppose the suction is happening on the top of the piston, compression will be happening on the bottom of the piston. So the crankcase also takes part in the operation of the engine. Here for the working of the engine, so there are three ports are there. So first we need to identify the port. So one is the exhaust port, another is the inlet port, and the third one is the transfer port, right? So here I am showing the different ports over here. So here the one which is connected to the silencer. So this is here the silencer of the engine will be connected here, and right. So the one which is just above this is going to come to the top. So this is my exhaust port, right? So this is my exhaust port. And you see the transfer port. So this is the transfer port. So there are two transfer ports which are diagonally opposite to each other, which basically transfers the charge from the crankcase to the top of the piston. So this is my transfer port, and so the inlet port is actually provided on the inside the crankcase. So inside the crankcase is my inlet port. So here it's a petrol engine, so the air fuel mixture is supplied by a carburetor. So this is my carburetor. So my inlet port is situated here, and you need to mark inlet port opening, inlet port closing. Similarly, exhaust port opening, exhaust port closing. So here also I can make this is my pointer. So with respect to the pointer, I need to first mark TDC and BDC. So you just rotate this. So when the piston reaches the topmost position here, so this is the piston has reached the topmost position, I just mark the TDC here. My BDC would be diagonally opposite to this. So mark TDC here, and 180 degrees from that you mark BDC. And now I need to mark the inlet port opening and inlet port closing. Here a two-stroke engine, you can just do it the experiment either rotating clockwise and anti-clockwise, there won't be any problem. So now you just look this. So this the flywheel actually blocks the inlet port, right? So if you are rotating, when there is a slot in that, when the slot begins to appear, so that is my inlet port opening. So if you continue to rotate this, now this is the slot here. You can just focus. Yeah. So now this slot is actually begin to open. So this is my so when this just crosses, this is about to open, then here you mark it as inlet port opening, right? So now this inlet port is now completely opened. Now it started closing, right? So at this point it is now completely closed. So IPO, IPC, both the points you can mark here, right? So next I need to mark the exhaust port for opening and closing. For marking the exhaust port and opening and closing, so generally when the piston is at TDC, when it is coming down, first my exhaust port would open, right? So I am just making the crankcase to rotate so that the piston is coming down. When here the ports are opened and closed just by the movement of the piston. When the piston just uncovers a particular hole, then that is my port opening, right? Now here you can see that. So this is the port hole which is connected to the exhaust port. Now it has opened. So now there is a small gap here, this which begins to appear. Now this is as the port has completely opened now, right? And now it started closing. When it started closing, when this hole is completely covered, now my exhaust port is closed, right? Similarly, you always find that, so during the downward motion, first my exhaust port would open, a little later my transfer port will open. So the transfer port, the slot is here. So when the piston just uncovers that slot, that means my transfer port is opening. So here, so we are seeing that just this piston uncovers this slot, that means my transfer port is open, right? So now we find that both the exhaust port and as well as the transfer port is also in the opening position. So during this time, what is known as scavenging will be happening. As the piston is coming down, whatever the charge that is taken in the crankcase, that will come onto the top of the piston. So that will remove the exhaust gases through the exhaust port, and there is a possibility that the fresh charge may also escape with the exhaust, right? So that is the problem with the two stroke engine. That's why the efficiency is less. So little later, now it will close the transfer port first, then little later the exhaust port hole would be completely covered. So each of these events, exhaust port opening and exhaust port closing, you need to mark, and similarly transfer port opening, transfer port closing, you need to mark, and you need to measure the angle closer to the dead center, and you need to diagrammatically represent this in a diagram, which is so here. So entire cycle is closed in, completed in one rotation of the crankshaft. So you draw a circle, right, and you mark your TDC and BDC here, right. So during suppose this you are measuring with the clockwise direction. So when the piston is coming from TDC towards BDC, we will find that first my exhaust port will be opening here, little later my transfer port is opening, right. So accordingly you mark the exhaust port opening and transfer port opening, and when the piston moves from the bottom dead center to top dead center, here first my transfer port will be closed, and little later my exhaust port will be closed. So generally you will find that exhaust port opening, transfer port opening, EPO, TPO towards BDC, after BDC, TPC and EPC, the exhaust port closing, right. So all this is happening on the top side of the piston, whereas the inlet port is opening on the crankcase. You find that somewhere closer to the TDC here my inlet port will be opening, and somewhere here my inlet port will be closing, right. So you just draw this circle, mark all these points, and so mention the various events here. You can also mark what is the angles with respect to the dead center, and this completes your port dynamic diagram. Okay.